Hello everyone, welcome to my presentation at Redisconf. My name is Jitendra Yadav. I'm a software architect at Verizon, and today I'm going to talk about real-time distributed tracing for microservices with Redis. So I'm going to start with discussion of, with start my talk about describing difference between monolithic and microservices, and I'll go into introduction to distributed tracing and why it is necessary for any kind of microservices platform and where it is really necessary and why do you need it. And then I will go into usage of Redis for real-time distributed tracing. So the term microservices has become very popular now, and we have been there are so many used cases where the use of microservices have been increasing day by day. But how it is different from the previous architecture? So previous architecture was a monolithic architecture, and in this architecture, this was a traditional architecture where all the software stack you normally have in a single unit, or you run the complete software stack as a single one piece of software. And this is designed for a self-contained environment. In a monolithic environment or architecture, interconnected and interdependent, the softwares are interconnected and interdependent rather than being loosely coupled, as in case of modular software. With monolithic architecture, each of the components are associated with their components, and the codes are together and executed, and even if you want to compile, they all have to be compiled together. So this is also a problem when you are trying to implement your CI/CD, and any compilation and execution of your monolithic architecture application is going to take time. Now I'll be moving to microservices and what is the difference it brings to the table. So the difference between monolithic applications and microservices architecture is your applications here are broken into smaller pieces, and they are divided into independent services. So what is the advantage of this? So the advantage of this is if you have an application which is a group of applications, just say you have a web application, a LAMP stack, where you have Apache, PHP, MySQL, and even include Redis. Now you can separate all of them together, or you can break them down into pieces of softwares, and you can deploy those services separately in your cluster or network. And you can also do independent development of those services. And the most beneficiary people from microservices are going to be always development teams, which can use the language of their choice, and they can develop the services faster. They can do it separately. There is not much dependency with other components, so their development is always faster. In microservices, large complex applications can be divided into smaller building blocks of executable, and each of the components and its associated components are present in a separate code, and they can be executed separately, and compilations are done separately. So what is the reason of microservices becoming so popular? And I would say one of the very important things which has made it popular is emergence of container technology. Container technology has been the force which has actually guided popularity of microservices. And advantage of microservices is it also helps you to actually scale your applications, and you can scale your services independently. So for an example, in a LAMP stack, if you want to scale your MySQL database, you can scale it separately. You want to have 2 front-end instances. You want to have, say, three MySQL instances. You want to scale only MySQL, you can scale it separately. You don't have to be dependent on the front-end instances, so you don't have to actually go ahead and do a complete scalable solution for each of the components. Another advantage of microservices is when you want to upgrade your microservices, you don't have to depend on, you don't have to bother about upgrading every component which is part of complete application stack. You can go ahead and upgrade your service which is required to be updated. If there is a code change and there is a upgrade for that specific service, you can go ahead and upgrade that service. So in terms of scalability and upgradability, you have lots of advantages of microservices. And additionally, as compared to monolithic application, microservices do provide you a lot of gain for performance, and a very big gain is usage of the resources in the data centers. So monolithic applications are always going to use a lot of resources, while if you talk about microservices, which are primarily, till now, mostly towards container technology, things may be changing a little bit more in future, but let's only think about container technology. You are going to utilize less resources with container technology as compared to monolithic applications. So what are the common orchestration tools available for microservices? I'll start with DCOS. I know Kubernetes has become a lot popular recently, but my first microservices platform was in early 2014, and it was, at that moment, it was not even DCOS. This is a Mesosphere product, and it was only known as Mesosphere. In 2015, there was product rename, and there were a few more components added, and it was known as DCOS. It's a very good orchestration tool. It provides you everything which you need to orchestrate a container technology solution and run your microservices in a scalable, self-healing manner, distributed manner, and it provides you lots of features which is really necessary. Kubernetes has recently become a lot popular. However, we are running DCOS in production for almost 5 years, and it's a great solution. It helps. It is a great orchestration tool for microservices, and still, there is something missing, which I'll come to the point in my next slide. But let's see, with current microservices architectures, the most important thing what you have is dependency over container technologies, and the container technologies which are being used right now is Docker, and the other option is LXC. Docker is also a wrapper over LXC, and you may hear this term LXT. If it is not popular right now, maybe in some time it may become popular. It is again a wrapper on top of LXC, which is providing a lot more user-friendly container technology over LXC, and it actually overcomes lots of problems what you have right now, even with Docker. So it is a little heavier stack than LXC, but still it has lots of advantages in terms of features lacking in Docker at this moment. So we have a very good orchestration tool, I'd say two. When we talk about comparing Kubernetes with DCOS, the difference is going to be, I would not directly compare Kubernetes with DCOS. I would compare DCOS with one of the component. I would compare Kubernetes with DCOS component called Marathon, which is a framework which allows you It exposes APIs and allows you to interact with DCOS and allows you to orchestrate. It also gives you a very user-friendly UI from where you can deploy your application. So when you deploy your applications on microservices architecture and your services are broken, your application is broken into very small pieces, so you assume that now your complete application is not just one application, it is many applications, and all those services are finally going to form a group to work together, interact with each other, and that we normally call in terms of DCOS or Marathon an application group. And to deploy an application in a working mode, all these services should work together. An application group has to be deployed successfully. Now, as I said that microservices are great. It is really good. It helps you to scale. It helps you in many ways. It speeds your development. But there is one problem. So I'm telling you this from my experience since last 5 years, the problems which we faced. So the problem is when you adapt to microservices, you are going to lack tracing with most of the tools available in industry right now. So any good orchestration tool lacks a tracing. So why do you need tracing? So with monolithic architecture, when you are hit with some kind of issue, you want to debug the issue, your logs are available on the same system or on the same application, you can go and check the logs and find out what is going wrong. And you can attach a debugger and many other things. But now in microservices architecture, because your applications are spread and they are distributed as services in a cluster or maybe over different network. You can do that way also. So how do you trace those logs? Just for an example, you are deploying a front-end and back-end application based complete application group. Now, it consists of front-end database, Redis, and few more components if you want to. Now, the system is being accessed by a user, and user complains that the user is not able to access the system or not able to log in. Now, you need to find out what is the issue. With a monolithic architecture, you would straight away go in the system and find out, or if you get log of that system, you can find out what was the issue. It's not so difficult to find out. Now, with microservices architecture, the problem is when you are deploying one front-end type of application or a back-end type of application, you're not only deploying one instance of front-end or back-end, you may be deploying multiple instances of front-end and back-end applications. Now, once the request is received to you, whether you find it out from your load balancer or whatever is the entry point of your network, that the request was received by you, then you want to trace it. Now, you want to trace it, so which instance log you are going to trace, that's very important. Now, the problem, because we had been one of the early adopters of microservices, the problem is debugging microservices architecture. Now, you have to jump if you have your own platform and you have access to the system. Normally, for security reasons, you will not allow this. But say your DevOps has access to the systems, and you allow SSH, and they can go to all the systems and do Docker logs. So right now, I'm talking about Docker containers. So normally, you will get the logs from Docker using Docker logs. Now, you have to first find out on what system your instance is running, which you think that is impacted. You go to that instance, you log in, and you do Docker logs and try to find out a specific log for that instance. Now, again, you think that, OK, I did not find anything else. Now, you have to jump to another machine where your currently instance is running. Then you find out for another instance. And maybe if you don't find any problem with front end, then you go to back end. Then Redis database instances. So this is a long process, and it's really a pain point for adopting microservices unless you have a tracing system which gives you a way to very easily find out what is happening in your system at a central place. So DCUS does have something which provides you logs, but that's not something which gives you a pointer where is the problem going on. You have to filter all the logs, collect it, read it, and that again is a time-consuming process. So for this problem, you have solutions in industry, and a couple of softwares which are available for this is Jipkin, AppDash, OpenTracing, and Jagger. OpenTracing is open source, so you can use it, and you can actually easily embed it to most of the platforms, and it's not so difficult to integrate. But there is a need for a system like this, and there are more softwares evolving like this. Based on the popularity of microservices, there is more demand for this kind of solution. No. With all these tools, you will still find there is something missing. Now, you can do distributed tracing, but being real-time is very important in a critical situation where you want to debug the log immediately, because if you want to debug log after some time with the historic logs, it's fine. But even if you don't have a real-time requirement, it's okay. But with historic data also, if you are logging, the logging is going to be huge. It is going to be piled up. So in this talk, I'm going to be concentrating more about being real-time and to be real-time, it is very important that you need to have a software stack which can actually handle millions of reads and writes per second and actually serve your requirements as on demand. So Redis provides you Redis stream. This architecture provides you a very fast read and write stream based on producer and consumer pattern, and that can be used for implementing real-time distributed tracing with Redis. So how would you actually plan to do this? So for example, you have Docker containers running on the compute nodes. You will have to actually ship the logs of Docker containers to Redis stream. And that you have to do in any case. Even if you are doing a normal log shipping architecture, something like using Kafka or any other solution, you have to ship the logs. Unless you ship the logs, you cannot actually analyze it at a central place. So in this scenario, you can have one client running on each of the compute nodes, which will be a producer, and that can stream the logs to Redis stream cluster, and it can be used by the consumer. And the consumer in this case can be your API, but to make it more user-friendly, you would think of making it an application which is a web browser-based application. So you would consider having a web application, and you would like to do live polls on the Redis streams, on the Redis cluster, subscribing to one of the streams which you are interested in. So previously, I discussed about application group. And application group is something very important, because you want to find out application of complete group. not a single instance. You can also find out information about a single instance or a single service, but to understand complete log, you would like to know about complete application group. So one application group may have front-end and back-end services, so you would like to know complete logs in real time. So when you are trying to find out logs in real time, you actually get more related logs, what is really happening one by one in timestamp. So you can actually relate to the sequence, and you can find out what went wrong and where the traffic went wrong. So it's easy to trace. And Redis being in-memory database and being so fast, it is really very useful, and you can use Redis streams for applications like real-time messaging, analytics, and data backups also. There can be a lot more usage of it. You can also use it for alerting, real-time alerting based on log analysis, in spite of doing some offline log analysis and generating alerts after, say, 5 minutes or 15 minutes or maybe later. So you can use it in a better, you can use Redis stream to better utilize it for distributed tracing as well as alerting systems. And this is one example architecture. It doesn't have everything which I have worked on, but still it should give you an idea, where you have a compute node where you have a producer which is going to send streams as logs from the compute nodes, and it goes into Redis cluster, and distributed tracing front-end consumer is going to consume it and find out logs based on your search query for the application group for which you are interested to see the logs about. Now, you may not want to actually expose the logs just openly, so you may want to implement some kind of security. So in case there is an API gateway or you want to implement security there, you would like to implement multi-tenancy and authorization and authentication kind of mechanism. So that's one of the things which you may want to consider. And at the same time, when you are getting all these logs, you can do some kind of monitoring from the Redis stream and do some alerting engine. And that will be done by group consumer. I'll show a couple of commands in next slides. I don't have a demo in this presentation, but you can download the demo application. Sometime I'll upload next week. I'll share my GitHub account, which you can access and download it if you want to try the demo application. So the first link is a Redis documentation, Redis lab documentation, which provides you good information about Redis streams and all the commands which are available with Redis streams. And when you are developing the producer, you would actually consider to use some programming language of your choice and write the producer in that programming language. But right now, I'm going to show you a couple of commands, which is using Redis CLI. And if you want to implement a real-time distributed tracing with Redis, then you can actually do an equivalent of code implementation in the programming language which you want to choose. So I'll be uploading my demo application in my GitHub account. Here is the link if you want to take down. OK, so what kind of messages you would like to send to Redis stream? That's also important. So you are, say, on one compute node, and you have a client which is a producer of the Redis stream. And most importantly, what kind of messages you would like to say. So you on the compute nodes, say you are running a couple of microservices, and you are interested in sending logs of all those microservices. They are running as Docker container. So ideally, you would like to send hostname at least, because from where this log is generated, on which machine this was running, you would like to find out. Then you would like to send information about what is the name of microservices. So every microservices if it is running as Docker container, would have a Docker container name. So you would like to say that. You would like to send the timestamp, and you would also like to send the data payload. So data payload will be the actual log message generated from the Docker containers which you want to send it to Redis stream. Now, when you are implementing this in your code, you would actually like to subscribe to Docker events, because you cannot schedule something and keep reading Docker logs one by one. So better subscribe to Docker events and subscribe for the logs being generated for the containers, and based on the event being triggered, you can you can fetch the logs and send it to Redis streams. So here is one example of, these are the commands which are going to be useful for you. And if you go back to my previous GitHub link, you can see complete list of commands and the results of the commands present there. So you can try that if in case you want to give a try to Redis CLI. But before doing that, you will have to run Redis with module loaded, with Redis stream module loaded, or you would like to run Redis 5, which has the Redis stream support. So the first command is actually you are going to add Redis streams to database using xadd command, and you specify the stream name, and then you specify key value, and key value. This is the way to actually send the data to Redis stream. Now, with the data key, the value is going to be the payload. As you can see in xadd lamp star host name, compute one, microservice, MySQL instance one, and then the payload. You can use xread command to find out the output of the streams which you added, and you can read it from Redis stream using xread command. Now there will be a scenario where you would like it to behave just like tail minus f. So you can use xread, the last command, which is xread block 0 streams my stream dollar, will actually behave just like tail minus f. So it will be a blocking call. So Redis stream also supports a way to actually allow you to have multiple subscribers actually reading one stream. And this can be very useful when you are trying to do some multiple analytics, alerting engine, some kind of AI performance, data visualization using log analysis. So this is going to be very useful in those scenarios. But right now, I don't have that implemented in my demo application, but probably I'll do it sometime later. And you can create groups with xgroup command. You can add the data same as xadd command, and you can read the group data using group monitor. The example is monitoring group member, count one, stream lamp. So it shows you complete list of data which is available, and data can be even it can be acknowledged by the subscriber when it reads the data. Now, when you have sent the data to Redis stream, finally you would like to implement a web UI, and you can do it in many ways. Long polling is one of the solutions, but RxJS is a good library which you can use. It's a JavaScript library which you can use for polling Redis stream, or you can also implement WebSocket or event source. Now, when you implement your web UI for this, you would like to actually provide multiple options for the user to either query your traces by application group name or a specific instance or a service, microservice name, or by date. It depends on your choices. What are the values you have put inside the data stream, and what are the filters you want to provide back to user. So, as I said, most of the orchestration tools for microservices still are missing this feature. There are additional tools which can provide you distributed tracing, but Redis is going to be a great choice in case you need to have a really fast, real-time distributed tracing. And the capability of Redis stream is really great. It can read and write millions of records per second. And the most important thing is it's very easy to implement. It's simple. It's rock solid support from Redis is one of the great things which I admire. And the important thing and the advantage it has over other solutions, like if you want to compare it with Kafka, is it is going to be really very light as compared to solutions which involve Kafka, and it may not have complexity of maintaining Zookeeper and other complex software associated with it. So I would say Redis is really a great choice for using it for distributed tracing, and that's my final thought about this solution with Redis stream. I'm open for any question. In case you have any question and you want to ask later, also I have my Twitter handler here. Yes.
How do you visualize your logs? Do you use a particular tool like?
So I've not completed my visualization, but my favorite choice is always going to be d3.js. So that's the library which I would actually use. There are other proprietary solution also, but d3.js has a huge amount of libraries, and already you have available sample codes which you can very easily implement. And
Hi there. Regarding the use of streams for this type of operations, and regarding the definition of tracing himself, aren't we using this as more as a distributed logging and not as a distributed tracing? Because you are only able to do one hop. You are not able to see the extent of the request from A service to B service to C service. You are only logging each individual request and not the relationship between them by using this type of. I totally agree that Redis streams should be used as a means for analyzing the tracing, but I believe that it would be more useful to use open standards like open tracing on top of Redis streams and not re-implementing ourselves and not reinventing the wheel as we are doing now.
Okay, so open tracing is still not going to be real time. That's my first take about this. Okay. Now, when I said I'm tracing it, I'm tracing application group. When you say application group, you are not tracing one instance.
Yes,
right?
you're doing log analysis by doing this. You're not tracing the request from the source to the destination.
So when you are taking the application group and you are doing a range query, right? So when you do range query by timestamp, you will get how long the logs should be, right? So when you do for a specific application tracing, you will get logs from all those instances what you have seen. Right?
Yes, but
so now you have all the logs for a specific time for all the instances. Now you will have to implement a little bit of filter, not too much, but you have a very much closer look at the logs, which is coming just straight away to you.
Just to finish up, I believe that what you're saying is more related to enabling different data visualizations for the same log. So you are applying different boundaries. So the service A will have pod 1, 2, 3, 4, and then you can associate with that pod number with the boundary as a service name. But this will not answer the question, for example, if service A is doing a request that can be traceable, to Redis or to database A or service B, C, D. This is only gives us visualization regarding one op, I believe.
So you'll get the logs, right?
Yes.
And every application logs and the call flow is going to be different, right?
Yes.
So unless you make a workflow, how to find out really tracing, it's not possible, right? So that's the implementation you will have to think in your code. If you can provide a configurability kind of thing for any application group, then it's possible.
This is more like Elasticsearch on steroids. This, but not open, but not tracing. This is log analysis, I believe.
Okay.
Yeah, to add to his response, yeah, I agree. This is more of distributed logging, because in tracing we trace basically the latency aspect between the services, and we also log the traces and the spans itself. That's what like open tracing and Zipkin does.
Yeah.
So my question was like, so, and we also use the correlation ID to pass through the logs, to correlate the logs for that particular request. So if we use the Redis streams, how is it going to tie into, like, say, Zipkin, for example, right? Because Zipkin right now supports HTTP transport and Kafka transport out of the box. So to read from Redis streams, we will have to implement something so that Zipkin will be able to read from Redis streams. So I think, yeah, to add to his point, we would be reinventing the wheel, right?
Not really. So I actually did not give you complete use case. So this is very much related to my next platform, and that next platform is mostly a robotic cloud. Okay, so I did not want to divert in everybody, but when you think about that, my real requirement was it has to be real time. Zipkin is not really real time. If you have used it, it's not, right? So I need to really filter the data very fast, and it's going to be based on couple of more logic, but not too much. So first thing is I have to get the data really fast.
So really fast means, like, because when we are also implementing a tracing system, and it's like pretty near real time. So when we talk about, like, milliseconds of, like, latency, when, like, in your particular platform or use case, what are you defining at, like, really fast or real time?
So you can also divide milliseconds into sub-fractions, and that's supported in Redis. I did not show you, but that's also supported. So you can actually do the sorting based on timestamp, and you will be able to actually find out. It's a very small fraction of time which gets divided. Even you can divide the milliseconds, and that's where you find out what's the real difference.
Okay. Thank you.
Any more question?
Hi, I was just wondering if there's any relationship with trace IDs and application groups.
Yeah, that has to be an implementation to be done as per your development requirement. Application group is really important because that you relate with the stream name. So with every application group name, you write it as a different stream. So that's where it gets separated in Redis stream. So your application group data are getting separated. And then ID, whenever you write any log, it always generates a ID in Redis stream. So this is something which has to be done per specific use case. Thank you very much. Have a nice day.